So another algebraic tree diagram. There are only n red balls and n plus 1 blue balls that are blue. 2 balls are taken from the bag, and we know the probability that both of them are the same colour is that algebraic expression there. We need to show that that is true. So thinking about our tree diagram, let's fill in the bits that we need. Both the same colour, well that would be at the end of this tree here because you'd pick blue blue, and this tree here you'd pick red red. So let's only fill in the properties of those ones. So at the start, the probability of picking a blue, well there's n plus 1 blue balls, and the total number of balls in the bag are n plus 1, which is 2n plus 1. And the probability of picking a red, well how many reds are there? There's n reds out of 2n plus 1. Okay, so looking at this branch here, I've already picked a blue, so there needs to be one less. So n plus 1 take away 1 gives me just n. And I've already picked one, so there needs to be one less on the bottom, so 2n. Well, I can cancel out those n's to just give me 1/2. What about this bit here? How many reds are there now I've picked one red? Well, there's n minus 1. And how many is that out of? Well, there's one less than 2n plus 1, so just 2n. The probability of picking this red is n over 2n plus 1 times by n minus 1 over 2n, which gives me n squared minus n over that there. So 2n times 2n gives me 4n squared. 2n times 1 is 2n like that. What about the blue up here? We've got n plus 1 over 2n plus 1. And that's going to be times by 1/2. So that one's nice and easy. N plus 1 on the top and 4n plus 2 on the bottom. We need to show this is true. So we have to show that n plus 1 over 4n plus 2 plus the probability of 2 reds has got to be the same as that. Well, in order to add these fractions, I need the denominator to be the same. So is there anything I can factorise on that second fraction to help me out? Well, I can factorise an n out of the top here, and I can factorise out an n from the bottom as well, and that will give me, on the bottom is going to be 4n plus 2, so I can cancel those out. And we can notice now that we've got 4n plus 2 and 4n plus 2 there. So we can then just add the numerators together. So I've got n plus 1 plus n minus 1. And that's all going to be over 4n plus 2. Moving up here. So how many n's on the top? 2n. And we've got plus 1 minus 1. So they're just going to cancel. Over 4n plus 2. Notice every single term in there is a multiple of 2, so we can factorise out a 2 from the top and factorise out a 2 from the bottom, which I can then cancel, and that gives me n over 2n plus 1, which is what I needed to prove at the start there.